A quick video on preliminary periodic table, chemistry, reaction kinetics, the combinatorial patterns of group 1 and group 2 metal oxides with the acids. It's a classic neutralization reaction. As you can see, the images posted in the community. Here we have sodium here going with the top three mineral acids. So the top three mineral acids are hydrochloric acid, sulfuric acid, nitric acid, and then you have these very exceptionally strong, halo acids, halogen acids, hydrofluoric and hydrobromic acid. These two, they're very, very strong, but they, because of ionization constant and pKa and minus log Ka, they aren't strong in actual terms, in calculational terms. But when they can dissolve plastics at a very, very they can dissolve concrete, and they're very corrosive. They are just phenomenally corrosive acids, these two. So hypobromic, hydrobromic, and hydrofluoric. And then you have these two weak acids. This is hydrofluoric. This is phosphoric acid used in Pepsi Cola, Coca-Cola. Only strong if you concentrate it. Otherwise, it's available. It becomes dilute a lot quicker as a lower ionization, hydroxonium ionization potential. So these three are the king acids, the king mineral acids, as I call them in my lectures. Hydrochloric acid, sulfuric acid, nitric acid, right? Mineral acids. And then what you do is you can say sodium oxide with hydrochloric acid gives you salt and water. With sulfuric acid gives you sodium sulfate and water. Sodium sulfate is a very important body salt. It's needed when patients are suffering from hyponatremia during operative procedures where there's been a sodium loss from the patient. And then we have, so when it reacts with nitric acid, it gives you sodium nitrate, which is used as plant fertilizer, and then water. So with hydrofluoric acid, it would give you sodium fluoride, which is also used as a salt in, and it's also used in toothpastes. So, and then with hydrobromic acid, it would give you sodium bromide, which is a monobasic salt. With carbonic acid, it would give you sodium carbonate, and which can further be modified to form baking soda, which is NaHCO3. With phosphoric acid, it would give you NaPO4, which is Na3PO4. So with phosphoric acid, it will give you sodium phosphate. Now we move on to potassium. And so when potassium oxide, it follows the same pattern. When it interacts with hydrochloric acid, it gives you potassium chloride. With sulfuric acid, it gives you dibasic potassium sulfate, precipitate. And notice the state symbols. Wherever it says aqueous, it means aqueous. The salt remains soluble within water. And where there's a PPT, it means it precipitates as a colloid. So when potassium oxide reacts with nitric acid, it gives you potassium nitrate, which is very important. So potassium sulfate and potassium nitrate are very important fertilizers, plant fertilizers, crop fertilizers, and they're sold in bulk quantities to farmers. With hydrofluoric acid, it would give you potassium fluoride. With hydrobromic acid, it would give you potassium bromide. With phosphoric acid, it would give you tribasic potassium phosphate. With potassium carbonate, I should have mentioned carbonic acid reaction, which is potassium carbonate formulation when potassium oxide reacts with carbonic acid H2CO3. So it will give you a weak compounds, a weak solution of potassium carbonate, which is very soluble. The reason, it's almost negligible, not detectable. When we come over to group 2, which is we take the 2' examples, calcium and magnesium, we can't use the others. So in group 1, we can't really use francium and cesium because they're highly radioactive in minute quantities and very rare. But we often use sodium potassium as a prime example. In group number 2, we don't use barium and strontium because they require higher temperature, hotter temperature acids. So with group 2, we use calcium and magnesium as prime examples. And so here we can see calcium and oxygen are balanced in the valencies. So it'll be a basic compound. So it'll be, calcium oxide reacting with hydrochloric acid, nitric acid, hydrobromic acid, hydrofluoric acid, carbonic acid, sulfuric acid, and phosphoric acid. And you can see the products: CaCl2, CaNO3 whole twice, CaBa2, CaF2, CaCO3, CaSO4, and then calcium phosphate. Calcium phosphate would be a precipitate, calcium sulfate would be a precipitate, calcium carbonate would be a precipitate, whereas calcium fluoride, calcium bromide, calcium nitrate, these 3 would be soluble, would not be very detectable, but they'd be there, elevating the pH of the solution from 1 to 7. You could use the litmus paper. Then CaCl2 will also be soluble, not very visible. Then you have magnesium oxide. This is what it does: magnesium chloride, magnesium nitrate, magnesium bromide, magnesium fluoride, magnesium carbonate, magnesium sulfate, magnesium phosphate. So the last 3 would be precipitates, optically visible due to when subjected to turbidimetric A equals epsilon Cl law. It's known as the optical density calculations, turbidimetric calculations, and it's it's where you check how cloudy the solution is by checking how less light it's allowing to pass through, and that law is known as A equals epsilon times the concentration of the solution in moles per dm cubed times the diagonal length of the test tube used in spectrophotometric analysis. So yeah, that would be, I'm forgetting the name. The name is it's a very popular undergraduate topic. So yeah, magnesium oxide interacting with hydrochloric acid, nitric acid, it's not. So there are many kinds of bromine variants, bromine acid variants: hypobromic acid, hydrobromic acid, hypobromate, hypobromic, hydrobromate. Do 2-3 different variants of bromic acid. This one is known as hydrobromic acid. It's the simplest one. Then you have hydrofluoric acid, then carbonic acid, sulfuric acid, and phosphoric acid. And you can check, I've balanced all the equations in every case, and it gives us magnesium chloride, magnesium nitrate, magnesium bromide. It gives us magnesium fluoride, magnesium carbonate, magnesium sulfate, magnesium phosphate. Magnesium is not a very popular, plant fertilizer. It's used in lesser amounts. But yeah, a large quantity of fertilizers consist of calcium, potassium, and ammonium salts for protein synthesis and strength of the skeletal structure of the plants. So yeah, that's pretty much it. I mean, I hope you enjoyed it. I'll upload this. This was from today's class, reaction kinetics, periodic table, periodicity, period patterns. So we will. I'm going to do another video on nuclear dev management, device management. It's a summary, and I'll upload it as well. It'll be a summary of BTEC nuclear device management curriculum, and I'll talk about the basic devices used in nuclear radiation diagnostics. All right then. Thank you very much. Stay tuned. Take it. Bye now.